Welcome back to our channel, where we explore fascinating phenomena and unravel the mysteries of the world around us. Today, we have an intriguing topic. How does air blow? Have you ever wondered why and how the wind blows? Join us as we dive into the science behind this natural phenomenon and uncover its secrets. Before we get started, let's understand the basic concept. Wind, or air blowing, occurs when air moves from areas of high pressure to areas of low pressure. But what causes these pressure differences? To answer that, we need to look at some key factors. Air blowing is primarily caused by the movement of the Earth's atmosphere. The atmosphere is the layer of gases surrounding our planet. It consists mainly of nitrogen, oxygen, and traces of other gases. As our planet rotates, it creates an uneven distribution of heat. The equator receives more sunlight, making the air near it warmer compared to the poles. This temperature difference sets the stage for the movement of air. Air blowing occurs when there is a difference in air pressure between two areas. Air pressure is like a push from the air particles all around us. Think of it like a crowd of tiny invisible particles that surround everything. Just like you feel pressure when you press your hand against a wall, the air particles are constantly pressing on objects and surfaces. Now, this air pressure is happening all around us, not just on balloons. It's present on the walls, the ground, your skin, and everything else. We can't see it, but it's always there, exerting a gentle force on everything it touches. Air pressure refers to the force exerted by the air particles on a given surface. Imagine you have a balloon filled with air. The air inside the balloon pushes against the walls of the balloon, creating pressure. Similarly, the air around us exerts pressure on objects and surfaces. Near the equator, the sun's rays are more direct, causing the air to heat up. Warmer air expands and becomes lighter. As the air near the equator gets warmer and lighter, it rises upwards. This creates an area of low pressure at the surface. On the other hand, near the poles, when the air gets colder, it becomes heavier and wants to sink down. This creates an area where the air is pushing down more strongly, which we call high pressure. It's similar to when you open a door between a crowded room and an empty room. The people in the crowded room will naturally move towards the empty room to balance things out. In the same way, when there is a difference in air pressure between two areas, the air flows from areas of high pressure to areas of low pressure to equalize the pressure differences. It's like when you have a big pile of toys on one side of a room and an empty space on the other side. The toys will naturally move from the pile to the empty space to even things out. In the case of the air, it moves from areas of high pressure to areas of low pressure. This movement is what we feel as wind. This movement of air is what we perceive as wind. It can be a gentle breeze or a strong gust, depending on how big the pressure difference is. The bigger the difference in pressure between the two areas, the stronger the wind will be. So, the next time you feel the wind blowing through your hair, remember that it's the result of air particles moving from areas of high pressure to areas of low pressure. Just like a natural balancing act, nature abhors imbalance, and the movement of air is the Earth's way of seeking equilibrium. Air flows from areas of high pressure to areas of low pressure to restore balance. This movement is what we perceive as wind. But it's not just temperature differences that contribute to wind patterns. Factors like the Earth's topography, the presence of water bodies, and even the Coriolis effect play significant roles. The Coriolis effect, caused by the Earth's rotation, deflects the path of moving objects, including air masses. In the northern hemisphere, the deflection is to the right, while in the southern hemisphere, it's to the left. This effect influences the direction of the wind, creating distinct patterns across the globe. As wind moves across the Earth's surface, it encounters various obstacles such as mountains, buildings, and trees. These obstacles cause the wind to change direction, speed up or slow down, creating gusts and turbulent airflow. One of the best examples of pressure-driven winds is the trade winds. The trade winds are global wind patterns that blow consistently toward the equator from the subtropical high-pressure zones. After the air rises near the equator, it eventually cools and descends in the subtropical regions. This creates high-pressure zones known as the subtropical highs, located around 30 degrees latitude in both hemispheres. The air from the subtropical highs flows toward the equator to replace the rising air. Additionally, weather systems like high and low pressure systems, fronts, and jet streams can greatly influence wind patterns. These systems result from complex interactions between temperature, humidity, and atmospheric pressure, giving rise to weather phenomena like storms, rain, cyclones, and heat waves. During a heat wave, winds can blow from regions that are experiencing higher temperatures toward areas that are relatively cooler. Rainfall. Wind movement is also closely linked to rainfall patterns. One major factor is the transport of moisture by wind, which affects the availability of water vapor in different regions. When the wind blows over bodies of water, such as oceans or large lakes, it picks up moisture in the form of water vapor. The wind then carries this moisture-laden air mass to other areas. When the wind encounters barriers like mountains, it is forced to rise. As the air rises, it cools down, and the water vapor condenses to form clouds. So, as we've learned, the wind is the result of air moving from areas of high pressure to low pressure, driven by temperature differences and influenced by various factors, such as the Earth's rotation, topography, and weather systems. That's all for today's exploration into the captivating world of wind. We hope you found it fascinating and enlightening. If you have any questions or want us to cover more topics, please leave a comment below. Don't forget to like this video and subscribe to our channel for more mind-blowing content. Until next time, keep exploring and stay curious. Thank you for watching.